Yeah, I'll go over the answer. I have actually completed the last line that I was writing, and I'll just go over the proof, and then we will do it for root 5, which is in your exercise. And then root 3, I'll suggest that you try writing yourself. So just going over what we have done here, we are using the method of contradiction here, and I have started by assuming opposite of what I want to prove. So I want to prove that root 2 is irrational, and I have assumed that, let us say that root 2 is rational. If root 2 is rational, that means it can be written in the form p over q, where p and q are two integers. That means it can be written as integer over integer. And the denominator cannot be 0, so I have to write down q is not equal to 0. And I would like this rational number to be in the lowest terms. That's why I have written that p and q are co-prime. p and q are co-prime means इनकी further cutting possible नहीं है, हमारी fraction lowest terms में है. And अगर इसको हम technically बोलें, then p and q have no other common factor than 1 itself. The only common factor p and q have is 1. 1 के अलावा इनका कोई और कॉमन फैक्टर नहीं है. एंड लेटर ऑन हम ये शो करेंगे कि p और q का कोई और फैक्टर एग्जिस्ट करता है 1 के अलावा, विच विल मेक देम नॉट को प्राइम. तो यहाँ से कॉन्ट्रडिक्शन आ जाएगी कि हमने जो अज्यूम किया था वो चीज़ गलत है, वो पॉसिबल नहीं हो सकता. So from here I've simply written root 2 equals to p by q, then cross multiplying I get the value of p, squaring both sides. So there are few steps you want to remember कि कैसे चलना है. सीधा रट्टा मत लगा लेना, please don't cram it just as such. Try to understand and then learn. So I have squared both sides so that I don't have the root 2 thing anymore, the one which is actually creating the problem, जिसकी वजह से question है हमारे पास. अगर ये होता ना तो शायद question भी नहीं होता. तो let's first deal with that. Square both sides. 2q square equals to p square. So p square is actually written as the product of 2 and q square. दो वैल्यूज को मल्टीप्लाई करके p स्क्वायर बन रहा है, तो वो दोनों वैल्यूज जो होंगी वो p स्क्वायर के फैक्टर्स हैं. सो 2 and q स्क्वायर आर फैक्टर्स ऑफ p स्क्वायर. बट मेरा q स्क्वायर से कोई कंसर्न नहीं है, मुझे पता ही नहीं q है क्या. 2 का मुझे पता है, सो लेट्स वर्क विद 2. 2 इज अ फैक्टर ऑफ p स्क्वायर. एंड हियर आई एम गोइंग टू अप्लाई माय थ्योरम कि अगर 2 p स्क्वायर को डिवाइड करता है तो वो p को भी डिवाइड करेगा. एंड अगर हमारा जो इंटीजर है p वो 2 से डिवाइड हो रहा है, दैट मीन्स वो 2 के टेबल में आता है. तो 2 के टेबल में वो कहाँ पे आता है, मैंने ये लिखा है. तो कोई इंटीजर होगा m, जिससे अगर हम 2 को मल्टीप्लाई कर दे तो आंसर p बन जाए. फॉर एग्जाम्पल इफ आई से 2 डिवाइड करता है 10 को, तो 2 के टेबल में 10 आता है. कहाँ पे आता है, 5 पे आता है. तो दिस इज व्हाट आई एम सेइंग हियर व्हेन आई से कि 2 p को डिवाइड करता है मींस 2 के टेबल में p आता है कहीं पे. कहाँ पे आता है वो हम मान रहे हैं कि m पे आता है. So 2 into m gives us p. From here again I'm going to square my sides because I want to use the result that I initially had when I squared the very first result which I began with. So squaring both sides, I'm using the value of p square, which I have marked as star in the beginning over here, and I get on simplification 2m square equals to q square. I'm going to just mark it over here. So पहली बात जब मैंने थ्योरम लगाई है, मेरे पास ये रिजल्ट आया 2 के टेबल में p आता है कहीं पे, कहाँ पे आता है, m पे आता है. इसके बाद मैंने फिर से स्क्वायरिंग की है. स्क्वायरिंग करने के बाद जो मेरा इनिशियल वाला रिजल्ट था मैंने वो यूज किया है. उसके बाद सिंप्लीफिकेशन के बाद मेरे पास ये रिजल्ट आ गया. एंड दिस रिजल्ट एक्चुअली रिजेंबल्स द वन आई हैड अर्लियर, जहाँ पे मैंने थ्योरम 1.3 यूज की थी उससे पहले. सो यहाँ पे मैंने फिर से थ्योरम 1.3 यूज करनी है. So 2 into m square equals to q square means 2 and m square are actually factors of q square. इन दोनों की multiplication से q square बन रहा है, तो ये दोनों q square के factors हैं. And again m square, I have no concern with it because I don't know what m actually is. I'm going to take 2 from here. So 2 is a factor of q square means 2 q square को divide करता है. And if 2 divides q square, then 2 will definitely divide q by theorem 1.3. सो आपके क्वेश्चन में 2 बार ये यूज होगी थ्योरम 1.3, और वो दोनों रिजल्ट से जो आप कंक्लूजन लिखने वाले हो दैट इज एक्चुअली योर लास्ट स्टेप. सो जहाँ पे मैंने 2 बार थ्योरम 1.3 लगाई है, उन दोनों रिजल्ट से ये पता चला कि 2 p को भी डिवाइड कर रहा है, 2 q को भी डिवाइड कर रहा है. सो पी और क्यू को डिवाइड करने वाला एक नंबर हमारे पास है 1 के अलावा. So this is what I've written. 2 is a common factor of P and Q because 2 is dividing P and 2 is dividing Q. But हमने तो ऊपर लिखा था कि P and Q को प्राइम है. इनको 1 के अलावा कोई और नंबर डिवाइड नहीं करता. There is no common factor other than 1. So ये आ गई contradiction. Contradiction to something we needed to assume or implement our assumption. जो assume किया था हमने beginning में उसको implement करने के लिए ये चीज़ होना बहुत ज़रूरी था. लेकिन इस चीज़ के लिए यहाँ पे एक contradictory result बन गया. So what we are going to say is कि हमने जो assume किया था वही गलत था and root 2 is not rational number, it is actually an irrational number. So we are going to write down, therefore our assumption that root 2 is a rational number is wrong. Let's write down the proof for root 5 and I hope थोड़ा सा आपको याद करना अंडरस्टैंड करना इजी हो जाएगा. If we write one more answer, example before the exercise where you have to prove root 3 is irrational, I would like you to write the answer yourself. And आपके पास उस केस में जो कॉमन फैक्टर आएगा वो 3 आएगा. रूट 2 के केस में 2 कॉमन फैक्टर बना था, रूट 3 के केस में 3 कॉमन फैक्टर बनेगा और रूट 5 के केस में 5 will be the common factor. Let's start with our exercise here. Root 5 can be written in the form P by Q, where P and Q are integers, Q is not 0, and the most important thing, P and Q are co-prime. Writing this is very important because इसी की contradiction आनी है नीचे. So let's deal with this root 5, and to deal with this we will have to square both sides. 5q square equals to p square, and यहाँ से हमें factors मिलेंगे. 5 and q square are factors of p square. If you want, you can skip this step. You can directly write down that 5 is a factor of p square. Sahaj, you have to only do example number 9 yourself, and example number 10 and 11 it will be easier once I do the exercise questions with you. After we do question 2 and 3 of the exercise, it will make sense to you how question 10 and 11 have to be done.
Okay, ma'am. Thank you.
So 5 is a factor of p square. In other words, we can say 5 divides p square. And now I'm going to apply my theorem 1.3. And the reason I'm writing this is because this is the result you want to mark as number 1. You'll need it later. So 5 divides p. And if 5 divides p, that means 5 के टेबल में कहीं पे p मिलता है. कहाँ पे मिलता है? Let us say we find it at a place m. There exists an integer m such that 5 multiplied by m gives you p. I'm going to square the sides again. Use the value of p square that you have over here. P square की value आपके पास. Now you have 5 multiplied by m square equals to q square, means these two are factors of q square. I'm not concerned with m square, I'll only be working with 5. 5 is factor of q square. And I'm going to use the theorem again here. Theorem 1.3 gives me that 5 is a factor of q. Or you could write down in other words, let's just use the same statement I used earlier, that it is actually dividing q. I'm insisting on this. Please don't learn it without understanding. You will mix up the results and you will forget steps in between. This is what happens. Okay, I think, is anyone else facing trouble with the screen? Like,
No,
No,
ma'am, it's clear.
no, ma'am. It's
okay,
clear.
if anyone's having trouble, please try reconnecting. So I have got result number 1 and result number 2, and as you can see, result number 1 and result number 2 clearly show that P and Q both are divisible by 5. But हमने तो beginning में कहा था कि इनका तो कोई common factor है ही नहीं. तो this is the contradiction that we have, and ये contradiction आती नहीं अगर हम कुछ गलत assume ना करते. So we are going to write down from 1 and 2, 5 is a common factor of P and Q, which contradicts that P and Q are co-prime. The students mostly learn these answers and they forget the steps in between, and the proof does not make sense. So please learn. I know this will need some learning because it's completely pure math. So it will require some learning, but you learn after understanding that what exactly is going on. Don't just write down the steps कि मैम ने स्क्वेयरिंग कराई थी, मल्टीप्लाई कराया था, बस कुछ फैक्टर फुक्टर लिखा था, लिख दो. It just then becomes like you are just writing whatever you remembered from your answer, and it won't make sense to me or the examiner. फिर वो ओवरऑल आपको दे के एक आधा नंबर दे देंगे ऐसे, चलो ठीक है कुछ तो लिखा है बच्चे ने. If anyone's writing down, please let me know.
No,
No,
ma'am.
ma'am.
Next question that you have is Question number 2 and question number 3. If you see, these are actually, yes, Shaunak? Shaunak, you've raised your hand. Do you have a question?
By mistake.
Okay. Question number 2 and question number 3 contain expressions where you have one value which is irrational. So the way to do these two questions will be same depending on how many marks such a question carries. You will first of all prove that the irrational part contained here is irrational. अगर आपको ये प्रूव करना है, फॉर एग्जाम्पल आपको क्वेश्चन 2 करना है, तो अगर ये आता है 3 मार्क्स में या 4 मार्क्स में, तो आप सबसे पहले ये प्रूव करोगे. First of all, you're going to prove this, that root 5 is irrational. फिर हम इस पूरे एक्सप्रेशन की बात करेंगे. And again, to prove that this expression here is irrational, I'm going to assume that this expression is a rational number. So let us say that 3 plus 2 times root 5 is rational. Again, method of contradiction. हम बिल्कुल opposite चीज assume कर रहे हैं, and this will mean that 3 plus 2 root 5 is equal to P over Q. And you will be writing down that P and Q are integers. Q is not equal to 0, comma P, Q are co-prime. And now let's simplify the result that we have. You can just cross multiply your values, or what I'm going to do is I'm going to find out the value of root 5. So this one's something you want to remember here, कि अपने expression में से आपको irrational part की value find करनी है. So I have transposed 3 from left hand side to the right hand side, and now I'm going to transpose this 2 to the right hand side. So root 5 will be equal to half of P by Q minus 3. Does anyone know who's Mahesh from 11th F?
Ma'am, he is Jannat's brother.
So at this step, if you simplify your right hand side, you will see that it's actually a rational number, and that can be written without doing anything. So what I have here is, if I just write down that this is a rational number, P over Q, right? And 3 is a rational number. So the difference of two rational numbers. I hope everyone knows. आपने लास्ट ईयर पढ़ा था. Difference of two rational numbers is a rational number. So आपके पास बन गया a rational number. ये ब्रैकेट का आंसर भी क्या आना है? A rational number. What can you say about product of two rational numbers? अगर हम एक फ्रैक्शन को एक फ्रैक्शन से मल्टीप्लाई करें, आंसर कैसा आएगा?
Fraction में.
Yes. So a rational number into a rational number is going to give you a rational number. So see what we have obtained here. मैंने आपको कहा था अपने इरेशनल नंबर की वैल्यू फाइंड कर लो, और हमें क्या मिला? उस इरेशनल नंबर की वैल्यू क्या आ गई?
Rational.
Isn't that a contradiction to what we proved earlier, that root 5 is irrational?
Yes, ma'am.
So you will write down that this contradicts the fact that root 5 is irrational, hence our assumption is wrong. हमने ये assume किया था कि ये एक्सप्रेशन रैशनल है, इसकी वजह से गड़बड़ हो गई। ऊपर जो प्रूव करके आए थे वही गलत हो गया नीचे। So this result right here, इसकी वजह से प्रॉब्लम आई थी। This assumption is incorrect. Is it clear what we're doing here?
Yes, ma'am.
Anyone with any questions before I complete the answer? All right. So you're going to write this down, and you can also write down here that product of two rational numbers is a rational number. Have you written this?
Yes, ma'am.
All right. Let's do
Yes,
question.
ma'am.
Let's do question number 3. So you have 1 by root 2. And again, अगर ये क्वेश्चन आपको ज़्यादा मार्क्स में आता है, हम क्या प्रूव करेंगे? फर्स्ट प्रूव that root 2 is irrational. If it's only for 1 or 2 marks, you can directly just write your answer. So we are going to assume the contradictory fact for this. I'm going to rationalize the left hand side. And my right hand side is the product of two rational numbers. The answer would be a rational number. I would like you to try the other two parts on your own, just like this one. And those also just contain a couple of steps, and then you can just write down that this is a contradiction. Anyone with any questions here? If anyone's writing down, please let me know.
Yes, ma'am.
And class is over at 9:30 or 9:40.
Then it will be over at 9:40, and I suppose you are here for attendance. I will not be marking
Done, ma'am.
I will not be marking the attendance for this class because the class is only for you. It's like fine, strength is so less. So the last exercise is based on few theorems that you have, theorem 1.5, theorem 1.6, and theorem 1.7. I will go over the theorems as such, and I will take a few examples to explain what this actually means. So theorem 1.5 states that if there is a rational number, that means it can be written in the form P over Q. And if that rational number has a terminating decimal expansion, then what can we say about its denominator? Is that the prime factorization of Q is of the form 2 raised to the power n, 5 raised to the power m, where n and m are non-negative integers. Non-negative integers are whole numbers. So अगर आपके पास कोई फ्रैक्शन है जिसको अगर आप डेसिमल फॉर्म में कन्वर्ट करते हो और उसकी डेसिमल फॉर्म टर्मिनेट होती है, it comes to an end after a certain number of digits, then you will observe कि उस रैशनल नंबर का जो डिनोमिनेटर है उसकी प्राइम फैक्टराइजेशन में 2 और 5 एज प्राइम फैक्टर्स प्रेजेंट होंगे. It is possible that the prime factorization of the denominator contains only 2 or only 5 or both 2 and 5. इनके अलावा कोई और प्राइम फैक्टर वहां पे प्रेजेंट नहीं होगा. This is what we have. This is what this theorem states. And below this theorem, they have taken a few examples to elaborate it further. Now, as you can see, all these rational numbers have their decimal expansions which are terminating. और उन्होंने तो किसी और तरीके से किया है. अगर आप वैसे अज्यूम करो 3/8 आप इसको पॉइंट्स में कन्वर्ट कर सकते हो, तो इसकी डेसिमल फॉर्म टर्मिनेट करती है. आपके पास सेकेंड एग्जाम्पल है 13 over 125. यू कैन क्विकली यूज योर कैलकुलेटर एंड सी कि अगर आप 13 को 125 से डिवाइड करोगे तो आंसर ये आता है 0.104 terminating decimal, and then 7/80 0.0875, and then they have taken this example, the last one 14,588 divided by 625, और इसकी डेसिमल एक्सपेंशन ये बनती है. सो आफ्टर अ फ्यू डिजिट्स पॉइंट के बाद आपकी डिवीजन खत्म हो जाएगी, रिमाइंडर 0 आ जाएगा, एंड दैट्स इट. अब इन सभी रैशनल नंबर्स की खास बात ये है कि अगर आप इनके डिनोमिनेटर्स की प्राइम फैक्टराइजेशन ऑब्जर्व करते हो तो इन सभी की प्राइम फैक्टराइजेशन में आपको जो प्राइम फैक्टर्स मिलेंगे वो 2 और 5 के अलावा कोई भी नहीं होगा, आइदर 2 और 5 और बोथ. And this is what they have done. Don't go looking at the whole of your examples, just observe this. This is the prime factorization, the denominator. So 8 की प्राइम फैक्टराइजेशन में सिर्फ 2 मिलेगा, 125 की प्राइम फैक्टराइजेशन में सिर्फ 5 मिलेगा, 80 की प्राइम फैक्टराइजेशन अगर आप देखते हो तो आपको 2 और 5 दोनों मिलते हैं, और 625 की प्राइम फैक्टराइजेशन में आपको सिर्फ 5 मिलेगा. तो अगर आपके पास कोई रैशनल नंबर है, आप उसके डिनोमिनेटर की प्राइम फैक्टराइजेशन करो, उसकी प्राइम फैक्टराइजेशन में डिनोमिनेटर की प्राइम फैक्टराइजेशन में अगर सिर्फ 2 नजर आ रहा है, सिर्फ 5 नजर आ रहा है, या फिर 2 और 5 नजर आ रहे हैं, तो उस फ्रैक्शन की जो डेसिमल फॉर्म होगी वो टर्मिनेट करेगी. और 2 5 के अलावा अगर आपको कोई और प्राइम फैक्टर मिल गया तो उस फ्रैक्शन की जो डेसिमल फॉर्म होगी वो नॉन टर्मिनेटिंग होगी. Does that make sense to you? हम रेपिटेशन की बात नहीं कर रहे, हम सिर्फ ये बात कर रहे हैं कि डेसिमल फॉर्म खत्म होगी या नहीं खत्म होगी. कब खत्म होगी? अगर डिनोमिनेटर में आपके पास 2 है फैक्टर, 5 है फैक्टर, या वो दोनों हैं, उनके अलावा कोई और फैक्टर नहीं है. And this thing can actually be used to convert your fraction into a decimal form without actual division. So I'm just going to show you how we can convert a rational number into a decimal form without division. So first of all, prime factorize the denominator. And then you have 2 raised to the power 3. Try to complete it and make exponent of 10. And to make exponent of 10, I require 5 cube. So I multiplied the numerator and denominator both with 5 raised to the power cube. The numerator will be simplified. So 3 multiplied by 125. This will give you the answer as 375. Whereas your denominator has become 10 cube, which is 1000. And then you can convert it into a decimal number. Let's take another example. 7 by 80. So you have 7 over. The first step is to prime factorize your denominator. The prime factorization of 80 will be 2 raised to the power 4 into 5. 16 5s are 80. So this is what you have. I would like to make my denominator an exponent of 10. So I need this. I have 2 raised to the power 4. I would like to have 5 raised to the power 4. And to complete that, I'm multiplying my fraction with 5 cube in the numerator and in the denominator. And after this, the denominator as such becomes 10 raised to the power 4, whereas the numerator on simplification, 7 multiplied with 125 gives me 875. And your denominator is now 10,000 and you can convert it into a decimal number. Let me know if this is making sense. Do you follow what I'm saying here? If anyone has any questions, please let me know because I would like to continue from here tomorrow. Anirai, did you leave the meeting in between and you just joined? So this is theorem 1.5. Similar to this, you have theorem 1.6, which states that if there is a rational number whose prime factorization for the denominator is of the form 2 raised to the power n into 5 raised to the power m, its decimal expansion will terminate. So these are the results. थ्योरम 1.5 में ये कहा था कि अगर हमारा रैशनल नंबर ऐसा है जिसकी डेसिमल फॉर्म टर्मिनेट करती है तो उसके डिनोमिनेटर की प्राइम फैक्टराइजेशन में हमें 2 और 5 के अलावा कोई प्राइम फैक्टर नहीं मिलेगा. यहाँ पे वो उसका ऑपोजिट बोल रहे हैं, द कन्वर्स, दैट हमारे पास जो रैशनल नंबर है उसके डिनोमिनेटर की प्राइम फैक्टराइजेशन में 2 और 5 के अलावा कोई प्राइम फैक्टर नहीं है, then the decimal expansion of that rational number will be of the terminating form. And then the last theorem is theorem 1.7, which states that अगर आपके पास कोई रैशनल नंबर है और उसके डिनोमिनेटर की प्राइम फैक्टराइजेशन इस फॉर्म की नहीं है, 2